be my job to kind of do it. And, I want to. This isn't too bad. This isn't too bad. I hear you. Mason, I feel your pain today. Kind of a Monday morning, snowy out again. Kind of back in the winter.
More of an ice house.
So.
It's not that icy.
Okay.
My whole car was covered in ice.
Carson.
Can't even open one of the doors.
Your classroom is fun during lunch.
Yeah, it is.
That's why I come here.
All right. Have I got everybody?
No.
Guys, 8.2 is going to start focusing on what we call linear equations in two variables. And guys, today, not too bad, the stuff we're going to look at. I think you guys did an awesome job in the last section being able to identify if relations are functions or not. We had two ways of doing that for each input. There is at most one, what's the word?
Oh, what?
For each input, there's at most one output. Okay, and if we were looking at stuff graphically, which line test were we talking about?
The vertical.
Vertical line test. And
I have no clue since I wasn't here.
That's right, Tim, I get it, and we'll talk about it when we get a second, okay? All right. Vertical line test said that if you graphed it, how many times can a vertical line hit your function? Just once. If it hits it twice, then we say it passes or fails, right? Okay. Well, today, guys, what we want to start doing is looking at some functions right now. And in those functions here, we talk about inputs and outputs. What we want to start looking at figuring out today here is finding solutions for equations in two variables. Basically, guys, saying if I know an input, let's see if we can't find an output, or finding solutions to determine if something's true. Okay. So real quickly, vocab-wise, if you'll take a look at all the vocab right here, I'll highlight it. All right, equation in two variables. How about a volunteer to read that first one for me?
I will.
I think I spelled it wrong. I spelled it like Tomskins. Tomskins.
Okay.
Like tungsten.
Okay.
Better than Lobwurst. Tungsten.
It's an oil.
It's an element.
It's okay.
Can I read now?
Yeah, go ahead, Mason. Thanks.
An equation with two different variables.
Okay, let me throw an example up here of an equation with two different variables. You might have something like y equals maybe 2x plus 7. That's going to be an equation with two variables. What are the two variables I'm talking about in that equation that I wrote as an example?
X and Y.
X and y, yep. Two different variables. X differs from y, so there's two unknowns there. Don't have a clue. Got a question though. What if I put in 1 for x? What's 2 times 1? 2 plus 7 would be what? 2 plus 7.
9.
9. Okay, he's multiplying. Alright? Guys, so you're saying when I input 1, y should be what value then? When I input 1 for x, what's the y value?
1.
No. What's 2 times 1?
212.
2 plus 7 more would be what?
9.
9. So when I input 1, what's the output have to be? 9, right? Okay. So the second part of this right here would say something like this. The solution of an equation in two variables is an x comma y that makes an equation true. Basically, I'm going to say for the one up above, 1 comma 9 would be a solution, meaning that when x is 1, what's the y value have to be?
9.
What if x was 2? What if x was 2 in that example? Plug 2 in for x and see what you get for a value. What's 2 times 2 now?
4. Yeah.
4 plus that 7 on the end would be? 11. You bet. So another pair or another solution to that equation would be 2 comma 11. It says a solution for two variables is any x comma y that makes an equation true. Okay. Okay, we'll talk about graphs of equations in two variables. It's going to be the set of points that form a line. I'll show you what a graph looks like here in a second. You'll see that. I want you to understand, guys, that everything we're talking about is a linear equation. What's linear? What do you think linear means?
Well, lunar.
Lunar has to do with the moon, but I don't know. What are we in astronomy now?
Yes.
It says linear equations.
I would love to have the astronomy class.
Linear equation is an equation whose graph is going to form a, what's the word? line. Okay, everything we look at is going to be linear here. So everything that we look at graphically is just going to form a straight line. Good there?
Yes.
Okay. Function form. Okay, this is going to be the part that's kind of difficult. We'll talk about what this means here in a second. But what function form says is this. It's an equation where what is alone? What's it say?
I got this. An equation where it is y alone.
Okay, when I say y is alone, I'm going to say this is an equation up top here in function form. Because on the left-hand side of the equal sign, what variable is the only thing over there? The y. So I say if this is what kind of form then, since y is all by itself? What's the name? What kind of form? Function form. Okay. Function form.
I think you mixed up your where and is. Or is it supposed to be like that?
Yeah, I did.
That was my
Mixed up y and is.
I
Okay.
keep sure.
Y is what though? Y is going to be all alone, right?
Yes.
Okay. All right. Let's start talking about this right here. First thing that they're going to ask you to start doing this, and this is to see, is a point a solution to a given equation? Okay. So in the first example up here, they want to know, is this point 5 comma negative 1 a solution to x minus 3y equals 8? Now keep in mind, guys, all points like this 5 negative 1 right up here, this 5 negative 1, written in an order that I just circled up there. The first variable or the first number is going to be plugged in for what?
X, Y.
And then the second number is going to get plugged in for what?
Oh, Y.
Y. So the question is this. It says in the bottom here, or number 1 I should say. Tell whether this point 5 comma negative 1 is a solution of x minus 3y equals 8. Now guys, we're going to basically be substituting values for x and y. And anytime you substitute something, you should always put water on that substitution.
Quotation.
Right,
Commas.
quotation. Starts with a P.
Parentheses.
Okay. So right here, I'm going to rewrite the equation. X minus 3y equals 8. What would take the place of x up there given this point? 5. So right here for x, I'm going to plug in a 5. Minus, all right, here we go. What's going to take the place of y?
Oh.
Negative 1. So I'm plugging these in, and I want to know if what's on the left-hand side is equal to what's on the right-hand side. So we've got some calculating to do. Guys, this becomes the 5 right here, minus, okay, what's this 3 times negative 1 right here?
That's negative 3.
So 5 minus negative 3 equal to 8. Hey, quick question here, guys. When I get to this point right here, when you subtract a negative, what operation is that really? It's adding, isn't it? When you subtract a negative, isn't that really addition? So isn't this really the same as 5 plus 3 equals 8? Is that statement true or false right there?
That's true.
5 plus 3 is 8, isn't it? So listen up here, kids. They want to know, is that point 5 negative 1 a solution to the given equation? Well, we plugged it in, and what kind of a statement did we get right here?
A true statement.
It's true, isn't it? So the question becomes, is 5 comma negative 1 a solution to this equation? What are you going to say? Yes or no?
Yes.
If your statement's true, then the point is a solution. So what I would ask you guys to do is this. Here are some points on your own. I want to know if these points are a solution to, here's your equation right here. Okay? There's your equation right there. I want to know, are those points a solution to that equation? So go ahead and give that a shot quick. Try them on your own. If you get stuck, chat with a partner, help each other out. I'm going to do attendance here quickly.
Does the parentheses mean you're timing the times in
I'm sorry.
Multiplying it.
the parentheses?
Yeah.
So like the negative.
So like the first one, 2x would be like 2 times the first value minus whatever the y value is.
Yeah, my grandma is obsessed with getting tattoos.
That's
She's gotten 5 tattoos in the past like 2 months.
midlife crisis.
No, she just like did it one time. Now
What, cat kept you up all night? Did your cat keep you up all night?
I don't know
What?
cat.
Then don't complain. You do not know the suffering until you have a cat. Until you have a cat and you try to go to sleep.
Okay, Mason,
It will
I don't
meow
just, like,
all
math
night.
questions, not a question. My cat doesn't keep me up all night.
Mine does.
Then keep your door closed.
She's just tired.
Next time I am not buying a Russian blue. I don't care what my mother says. I am not buying a Russian blue ever again.
Hey, Mr. Person, do you have
Those
those
things are
Pringles?
evil.
Mm-hmm.
I had to change subject, sorry.
All right, how are we coming along on this?
Nope, not done.
No? Maybe like 30 seconds.
Oh, this time, what I was your
I want more tea.
She's a man.
No? I don't know if I'm being this right person, but I'm going with it.
Trying the hardest.
That was keep.
I
I know. Tearing up.
All right, let's take a look at the first one, guys. What's going to take the place of x?
Dip.
What?
What's going to take the place of x?
0.
0, right? So this becomes 2 times what first?
2 0.
Whoops, I don't want that font. This is what I want. 2 times 0, right?
Yeah.
Minus what's going in for y?
Negative 5.
We want to know if that equals 5. Well, help me out, guys. What's 2 times 0 right here?
0.
0.
Oh crap! I got it wrong.
How about this subtracting of a negative? That's really what? It's like a double negative, so this is like plus 5 right here, isn't it? Can you see it right there?
Yeah.
So it's like plus 5. Guys, is 0 plus 5? 5? Statement true or false?
True.
True. So is 0 comma negative 5 a solution?
Yes.
Yes, it is.
I failed.
What do you guys think about the first one? You okay with that?
No. I
Well,
failed.
do you understand what I've got here, though?
Yeah.
Hey.
Wait,
Question, Taryn?
yeah, how do you get regular 5? Like, do you take the 2?
Well, the 2 times 0 right here was, this was a 2x, right? 2 times 0 is that value of 0, right? And then when you subtract a negative, this is what I'm saying, the opposite of a negative, which becomes
So 0 minus 5.
0, well, it's 0 minus negative 5. When you subtract a negative, it's like addition of the opposite, so adding a positive. So that's really 0 plus 5. You okay with that? Okay. Take a look at the next one here, guys. 2 times what first?
2 times 3 minus 2 equals 5.
Okay, so I've plugged everything in, rewritten everything with stuff plugged in. What's the 2 times 3, kiddos?
That's 6.
So 6 minus 2 is equal to 5.
Nope,
No.
it's equal to 4.
Is that true or false then?
That's false.
False.
I got this one right.
So yes or no on this one?
No.
No. What the heck was that? That was. Oh, that. What's that?
Okay, this next one's a little bit more difficult. 2 times what first?
2 times negative 2.
Minus what?
Negative 9.
Notice how everywhere, guys, when I, whoops, what's going on here? Everywhere where I've substituted, I put in parentheses, right?
C.
2 times negative 2 is negative 4, isn't it?
Yeah.
Again, here's this idea of subtracting a what here?
Negative.
So when I subtract a negative, what's that really going to be?
Positive.
Positive 9, right? So negative 4 plus 9.
Mr. Person, I have a question.
Yeah.
How come number 2 is false if it equals 5?
Well, if I would go one more step on the left, what's 6 minus 2 make? We get the door for her, Seth. What's 6 minus 2 make, Taryn? 4. And this is really saying 4 is equal to 5 now, which no validity to that, right?
I
Makes
bet I can
sense?
prove that.
But I'm
I just
curious
saw
on
that something.
if it equals 4, how come
Somebody
it's
was
5?
reading across.
I'm sorry. Hold on. Everybody quiet down. Say that one more time, Taryn.
If it equals 4, how come we put 5 in?
Because that's what was written in the original equation. we're trying to see if we put a point in right here, if the left side's equal to the right side. So they're saying, is this point, when you plug that in for x and y, going to give you a true statement or a false statement? Make sense? Okay, so that's what's going on here. All right, so we're at this point right here, guys. -4 plus 9 right here. Is that 5? Or in other words, this is like 9 minus 4, isn't it?
Yeah,
Okay, is that true or false?
that's false.
Ah,
That's true.
check it out, guys. You have calculators here. Go this route right now. Start with -4. Start with -4, and then just add 9. What's it get you?
-5.
Ah,
Ha! It's wrong.
positive 5, isn't it?
No, that's negative.
What?
That's
That's positive 5.
right.
There's more positives than there are negatives here, right?
Yay.
All right. So is that true or false? This one's true, right? So is that going to be a solution?
Ah,
What are you going to say, guys?
Yes.
Yes.
junction. What's your
Okay.
function?
So guys, anytime they want to know, is a point a solution to some kind of given equation in 2-variable form, your job, simply plug it in and see if your comparison on the left is equal to the comparison on the right. If the left side and the right side are equal, then it has to be a solution, right?
Yeah.
An example like in the middle, 6 minus 2, does 6 minus 2 equal 5?
Yeah. Wait, what?
Does 6 minus 2 equal 5?
No,
It doesn't. So what would you say about that point 3 comma 2 in the middle? Was that a solution or not?
not.
No. Right? So see if it's basically seeing if stuff turns out true or turns out false. All right.
Oh, I'm gonna die. I'm waiting to turn. Yeah, she's not. She's not coming back.
Oh my god, yeah, no. But like I have all the symptoms and stuff.
Whatever.
Dude, if I thought I was
Try to
internally
get out.
bleeding, I would go
Not
to
yet.
I
hospital.
feel completely
No,
fine
not
except
for like
sick and
8,
stuff.
like
Dude,
8.1.
most people that have internally
Right,
bleeding
8.1.
Yeah, I'll get. I
know,
sent it
so
home
my
with your
grandma's-
mom, so you should have
My
everything.
grandma was freaking out. She's like, we're going to
Oh, I don't
hospital.
have
Get
the-
the car. We're
no.
going to the emergency room. And I'm just like, no, I'm fine. She's like, you could be dying. And I'm just like, I don't care.
Whatever. Yeah, you do.
All right. Part that's going to get maybe a little more difficult here is going to be on the second page. So take a look there. Guys, this is what we're going to start looking at doing here, okay? Graphing a linear equation. And what does it look like graphically? And understand this. What kind of a graph are we forming here?
A linear equation.
That's pronounced
So-
linear.
So what, we're doing math at midnight?
It's pronounced linear,
So
okay?
we're doing math at midnight?
No, Tim, we're not. All right. Graphing a linear equation. This is not difficult to do. All right. Now, basically, what we're going to look at doing is graphing 3 points. And the idea here today is this. If in a graph I graph these 3 points right here, does it look like one straight line would go through all 3 of those points? We have set that up. So when you graph something today, you want to say, oh, yeah, it looks like it'll form a straight line. But if I graph something like this, all of a sudden, is one straight line going to hit all those points? No. So if you have points that go and form some kind of a triangle like this, something's wrong. Okay? Again, what's the idea here? Graph what kind of equations?
Linear.
Linear equations. You should see your 3 points forming what here?
A straight line.
Or one line will contain all 3 points. So let's go ahead and look at how we're going to handle this. This is really not too bad. Don't make this difficult. Last section was all about inputs and what? Outputs. We're going to do the same thing today. We're going to start forming some input-output tables for this. And this is how this is going to work. Here's how I want you to set this up. We're going to make T-charts for this. Okay? We're going to make some T-charts for this. Anytime we do a T-chart, we're going to put an X up here and a Y up here. Alright? Which variable are my inputs?
Inputs are
Mhm.
x's.
I can choose what I put into this, right? Okay? I'll make this very simple for you. I'm going to tell you to choose the following values for inputs. I'll have you choose your inputs the same all the time. Is that fair? That fair? These are the inputs I want you to choose. -2, 0, and +2. Actually, you know what? I'm going to change it this year. Forget it. We're going to go 0, 2, and 4. I'm going to change it up this year. Let's use 0, 2, and 4. Fair deal?
Ah,
Okay. Basically, I'm saying take 0 and plug it in for what?
X.
Take 2 and plug it in for what?
X.
Take 4 and plug it in for what?
X.
Okay, now I'm going to rewrite the way that this is written. This says graph negative x plus 1. I want you to write this as y equals negative x plus 1. You guys okay with that? All right, kiddos, here's how this works. We're going to come up to my equation that we're given up here. And the first thing I'm going to do is throw 0 in for what? Now, do you guys agree that this is really read as the opposite of x right here? Or I could also read this as negative how many x, guys and gals?
What?
How many x is this? This is really negative how many x?
1.
It's negative 1x, isn't it? Or negative 1 times x. Would you agree with that? Okay, so the first thing I'm going to choose to plug in is what?
0.
0. So what's negative 1 times 0 going to get you guys?
0.
0, right? And then 0 plus 1 more would be
1.
1. So this is really 0 plus 1, which is what value? What is it?
1.
So when I input 0, what was the output? 1. You guys agree with that? All I did is threw 0 in for x. Negative 1 times 0 is 0, plus 1 more is 1. Now what are you going to throw in for x? 2, right? So right here I'm going to take this 2 and throw it in for x. So this becomes negative 1 times what? 2. What is negative 1 times 2?
2.
Ah,
What?
negative 1 times 2.
Negative
Negative 2, and then negative 2 plus the 1 right here.
Negative 3.
So,
No.
No, guys, come on. Throw 2 in for x.
so we're not always using the negative 1.
Yeah, you're always using everything up here. This becomes negative 1 times what first? What's in for x now?
Oh, 2.
It's negative 1 times 2.
Oh, negative 2.
Negative 2. And then I need to take that negative 2 now and add what to it? 1. Negative 2 is here, move up 1. Where are you at? No.
Negative.
Negative 1, right? Throw 4 in.
Add your negative.
Negative 3.
Okay, so negative 1 times 4 is negative 4, right? Plus 1 more would be negative 3. Okay? So I put those inputs of 0, 2, and 4 in, and I've got an outputs 1, negative 1, and negative 3. You guys agree with that? Okay, well what the heck does that mean? Well, guys, honestly, we said all these points were x comma y values. So what I really have here is my first point, 0 comma what, guys? 1. How do you plot 0 comma 1?
Stay on the line
Stay here and then go where?
to the right.
Oh, up 1, right? Right? And
Yeah.
0 comma 1 right there. What's the next point I need to plot?
2, negative 1.
How do I get to 2, negative 1 from the origin?
You do right 2,
Right 2,
down 1.
right 2, and down 1. There's that point. Okay? Now I have a third point to make sure that that third point is in alignment with the first 2 that I have. So what's the third point down here? I'm asking you to check.
Right 4.
Right 4. So I'm going to go right 1, 2, 3, 4, and down how much?
3.
Holy cow. Those 3 points look like they're in a line, or do they look like they're going to form some kind of a triangle? Okay, and isn't that the idea here? We want to form some kind of a what here?
Linear.
Linear graph, and those 3 points would be it. So the equation of y equals negative x plus 1 is right here. And I want to show you something here. You just might want to grab a simple straight edge quick and draw your line. I'm going to draw mine up here. Here's what my line looks like. And it's a pretty good line. It's little. Let me fix it here just quickly. I think I can make it work. Okay, just checking this out right here, guys. We plotted these 3 points right here, right? Okay. I just want to ask this question. Does it look like this point right here is on the line that I've plotted right up here? it looks like that point is on the line, right? Okay. So my question is this, first of all, what point is that? Well, it looks like it's left 1, 2, 3, 4, left 4, and then up how much?
5.
-4 comma what?
5.
What that means is this, if the question came about and said, hey, after you've graphed this line, is the point -4 comma 5 a solution to this given equation? I would say, yes, this point is a solution because that point is on your what? Line. Here's a question for you. I don't care what this point is, but it looks like it's right 1, 2, 3, 4, 5, and up 1, 2, 3. Here's a point 5 comma 3. Guys, is this point 5 comma 3 a solution to that equation right there?
No.
Why not?
It's not on the line.
Not on the line. So what we've done here by forming a line here is to say, okay, this line is the collection of points that would make my equation true. So any point that's on the line, any point that's on this line would be considered a solution to this. Any point that is not on the line would not be a solution. Make sense? So what points do you want to make this true up here, guys? What points do you want to make that true? Points on the line or not on the line?
On the line.
On the line. On the line is good, off the line is bad. Okay? That's where the saying total line comes from.
Yeah, offline mode is definitely the worst.
Huh?
Making a joke, offline mode is definitely the worst.
What?
Offline mode, you know, like on the computer, so you're saying offline is bad.
Offline's bad, yeah. Yep. All right. I gotta see the last page here quickly. Okay. Guys, if I ever come back and ask you to form a graph right here, what are you going to use as inputs every single time?
0, 2, 4.
0, 2, and 4. Keep those the same. You're going to plug those into your equation, and those are going to determine your y value. So I plugged 0, 2, and 4 in here, right? Okay. Let's make sure our phones are put away, all right? Okay. Next one here gets more difficult. Well, I shouldn't say more difficult. I just want to make sure you understand the difference between the two. Okay. I can make this easy and short, or I can make this more difficult. What do you want to do?
Easy and short.
Okay, what kind of lines is example 3 asking you to graph?
Vertical and horizontal.
Vertical lines and
Horizontal.
horizontal lines. What's the first one up here that I'm telling you to graph?
Vertical. Oh,
What's that?
-2.
So I'm going to put y equals -2 up here. Now notice, guys, in this equation right here, is there just one variable or two variables now? There's just one, okay? Vertical and horizontal lines are only going to work with one variable. What's the x value I'm going to graph here?
3.
Okay. Here's the deal on these. I'm going to make this just short and not hit a lot of this. I think if you understand what's going on here, you'll really understand what's happening here. Guys, first example I have up here is y is equal to -2. Okay, so what this means is this. On the y-axis, they want you to go to what value? -2. So is my y-axis the vertical one or the horizontal one? It's vertical, right? Okay, so here's my y-axis. So on the y-axis, here's what we're asked to do. We're basically asked to go to this point right there. Do you agree that that's where y is -2 at?
Yeah.
Okay. What this is really saying then is draw a line This is really saying draw a line that crosses, come on, draw a line that crosses which axis here, guys?
Y.
At what value?
-2.
If I'm going to draw a line that crosses this axis, intersects it, is it going to be horizontal or vertical?
Horizontal.
Horizontal. Yep, it's going to be horizontal. It's going to look just like this. At -2, I want to draw a line that across right here. I want to show you something real quickly, just so you understand why this is the way it is. Before I do that, back up for a second. We got on which axis first?
Y.
Went to what value?
-2.
And then we drew a line that did what?
Cross
At what value?
-2.
Okay. That is only going to work when you have how many variables? 1 or 2? 1. I only have one variable in this equation. There wasn't an x and a y together in the same equation. It was just y all by itself, wasn't it? Okay, check this out, guys. I'm going to put a few points up here, and I want to see if you can pick this out. Guys, on that line, I've put down some points. On that line, I put down some points. Anything stand out to you or anything jump out at you about these points? -3, -2, 0, -2, 4, -2.
They have -2 in it.
First value or second value -2s?
Second.
Second value, right? Guys, all of these points that get written are written in the form x comma what?
-2.
X comma what?
Y.
Y, right? So the second value listed in all these are going to be what kind of values? X or Y?
Y.
Y values. What were all the Y values here?
-2.
Isn't that what you were asked to graph Y values of? -2 right there?
Yeah.
Wasn't it?
Yeah.
Okay. All right. So what do you think is going to happen in the next one, guys? Which axis do you think you're going to get on now?
X.
Okay, so I'm going to get on the x-axis, and where do you think you're going to go?
Y.
Where do you think you're going to go? What value?
Oh, 3.
3. So get on the x-axis over here. Whoops. Get on the x-axis. Run over to 3. Boom, boom, boom. Here we are. Hello. I'm at x = 3. That's a miss if you're playing Battleship. Any of you that have played Battleship know what I'm talking about?
Yep.
Okay. What do you think I'm going to write in front of the x = 3 now, guys?
Draw a line.
Draw a line that what? Crosses. Playing a little bit of crossy road.
Oh, yeah.
Crosses x at 3. Well, if I want to cross the x-axis, kiddos, am I going to be vertical, up and down, or horizontal, left and right? Got to cross this line. I got to cross this line, so it better be what kind of line? Vertical or horizontal, kiddos?
Oh, vertical.
Vertical. Get here. What? There be your line. There be your line.
I ain't talking in Shakespeare.
No. Shakespeare's the devil.
Yes.
Shakespeare's not the
Yeah, he is.
We read,
Thou artist, myeth, carveth,
Come find my
Oh,
soul.
we called-
envieth,
we did
arteth, oweth.
the
Come
Caesar
fight
thing
thy
by
self.
Shakespeare and
The matheth up thereeth is just as the thou. Okay, never mind.
Okay then.
If I ever saw Shakespeare, I'd deliver an opposite reciprocal.
No, that word, no.
Okay?
What does
What,
that
opposite?
mean?
Okay. Quick question, guys. If I wanted to draw a line for x = -2, where would you go first? X = -2.
X = -2 would be
First of all, where are you going? I
down.
want to graph x = -2. Where are you going? On the x-axis to what value?
-2.
So you're going to go left or right to start? Left. How many units? 2. So here's this -2. Here's the origin, here's -2. Am I going to draw a line up and down or horizontally through that point then? Vertically. Okay? Make sure you understand this. If it ever comes to vertical and horizontal lines, understand that vertical and horizontal lines are only in
Why is the
one variable form. Taryn, what's your question?
how come for the y it goes side horizontal and the x it goes up and down?
Because this is where it crosses the y-axis. Saying every point on this here, every point, the y-axis on this value right here, the y value was -2. Remember those points I plotted? 4 -2, 3 -2, 2 -2. What was true about the y value for all the points on this line? Well, they were all what value? -2, just like this one right here, Taryn. If I count right 3 and up 1, this point is 3 comma 1, right? If I count right 3 and up 3, 3 comma 3. If I count right 3 and up 5, 3 comma 5. What do you notice about all the x values in that point? They're all 3's, right? So if they're all 3's right here, that's the equation that you've gone ahead and satisfied right here, okay?
Yeah, but
Make-
I don't understand why the lines go different ways.
What do you mean?
Like, for the y, why can't it go up and down?
It can't go up and down because if it went up and down, Taryn, what's this point right here? -4 comma -2, right? Right?
Hey Carson,
Yeah.
can I borrow a few people from you?
Who are you looking for?
Mason, Thompson, and Madeline.
Mason Thompson?
Did you say Mason Thompson? Yeah.
I don't have Mason Thompson.
Yeah, Madeline.
Yeah.
Alright.
Yes, job.
I don't know who Madeline is, so
Maddie, go.
I don't know. You wanna fill this out for me? You wanna fill
Taryn,
it
right
out?
here. Look at this right here. Look at all my points up here that I've plotted.
I'll be back in like.
You read these are all points on the line, right? Okay. What stands out about all those points? What's -2? The x value or the y value? The y value is -2. Okay. So what we're saying is no matter what the point is right here, your y value always has to be -2. Okay. So this is what happens when you make all the y values -2. Different x's, but all values are -2. What kind of line does that form? Well, it's horizontal, isn't it? Okay. So when you do vertical and horizontal lines, just because this says y is equal to -2, it's going to run opposite of the y-axis. Okay. Because all these y values are what here? -2. Okay. So it's just the opposite of what you would think it would be. So if I say draw a line that says x equals something, well, the x-axis runs left and right. I think that's what's throwing you a little bit, right? Okay, what we really need to do is draw a line, and the key word here is what? Crosses it there. Okay. Got it?